Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all. So I'm Dr. Satimara binti Yusuf. So today I will share with you about soil compaction, specifically about standard Proctor compaction results test. So for this video is to show you how to calculate the compaction data. So okay, we know that when we're doing compaction, we can define the optimum water content and also the maximum dry density, and we have two different types of the compaction test, which is standard Proctor and also the modified Proctor. And the difference as follows, and this is the tools that we use in the laboratory, and the layout of the mold and also the hammer. And I believe you already learned how to conduct the test, and this is an example of the results that we have. So we have here is a mass of the moist soil for sample 1, 2, 3, 4, 5 and 6, and also together with the moisture content. And they also give us the volume of the mold, which is approximate to 1000 centimeter cube, and the specific gravity of 2.7, and also the density of water 1000 kilogram per meter cube. So what we have to do now is to do the compaction curve, and to define the maximum dry density and also the optimum moisture content. So what we have to do first is we have to calculate the bulk density, which is the mass of moist soil, the data that we have, divided by the volume of the mold. So we can get the bulk density, and next, after calculate the bulk density, we can calculate the dry density. And we also can calculate the zero air void curve. Alternatively, we also can check for 5% and 10% of the air voids by using this equation. So let's see the calculation in the Excel. So we know that the volume of the mold is approximate to 1000 centimeter cube, which is 0.945 to the power of 10 minus 3 meter cube. So how to calculate? So we take the mass of the moist soil divided to the volume, and we do this for all samples. We have to this one. And drag again. And then for the density, so we took the bulk density value and divide moisture content divide to 100, because we want to have the value in the decimal. So get the dry density, and we drag. So we got for all 6 samples, and then we can plot the graph. So I already plot the graph. So this is moisture content versus the dry density. Okay, note that the graph is in the range of it's not starting from 0, but it's starting from somewhere from 7 and end 21%. Similarly, for the dry density, it's not starting at the 0, it starts from 16,000 up to 2000. So 1600 up to 2000. So and please bear also that you have to plot what the to label what the percentage and also what the unit that used for the axis label. Okay, and we also need to calculate the void. So how we want to plot the zero and void is by calculating the dry density value at a certain moisture content location. So usually I suggest to you to have at least 3 different moisture content. So you easily pick the 14, 16.6 and 18.6 as your benchmark, as your location. You want to put a zero air curve here. Zero air curve here. So zero air curve usually at the top of the compaction curve. Okay, so we have a void equal to 0. So when we divide by 100, it's still 0. So this is example number 1 that I already calculated, which is I include the density of water, rho W, times the 1 minus C11, which is the air void, and divided to the 1 ratio to the specific gravity plus the moisture content. So I got the value here. So we can do that for the rest. Okay, check first. Should be here. Okay. Okay, and you also can calculate for the 5% avoids. So okay, I need to fill up this first. We have to change the percentage into decimal. So let's check because I tried it just now. Okay, I think this is correct. And do for the rest. Choose. Okay. So I got at least 2 lines. So you can see this is line for a void of 0. And this is for a void of 5%. So I already prepared the results. So this is the graph. So we can see that this is a maximum dry density at 1910 kilogram per meter cube, and the optimum moisture content is about here, about 13.5%. And we can also plot the a void of 0%. This is 0 a void curve, and a void of 5% means your compaction is okay, because your compaction is below 0 a void and a void of 10%. So I think that's all for this example. I hope later on you can proceed to study the sand cone method, because sand cone method also one of the calculation types analysis that you need to know in the in controlling the compaction that we have done in the field. So that's all. Thank you.